Hello everyone. In this session, we will discuss about the next type is enhancement type MOSFET. So what is enhancement type MOSFET? If you observe the structure here, there is no channel between the source and the drain. The channel should be enhanced. So by doing the operation, we should maintain the channel. We should getting the channel. Okay. So we have two types. One is depletion. Channel available between source and the drain, but in case of enhancement, simple thing, no channel between source and drain, so channel should be enhanced. That means channel should be generated between this source and drain. By using that channel, we will operate the MOSFET. That's why the title is enhancement type MOSFET. Okay. When we are getting the channel, whenever we are applying the voltage between gate and source, between these two terminals, when we are giving the voltage, the channel will be formed. That is the important point. So we should write here, whenever applying voltage between these two terminals, that is gate and source, the channel will be formed. Gate and source, the channel will be formed generally. So by using this channel, we will operate this enhancement type MOSFET. Okay. First intention is first thing we should channel formation. Then we should understand the operation. So by maintaining this gate and source voltage, by using this gate and source voltage, we will understand the channel. Okay. First, if the gate and source voltage is 0, there is no gate and source voltage, then what happens? So if there is no gate and source voltage means, so if we are giving, generally if we are giving, so normally we should give, so for this purpose we should give normally drain should be in negative biased, and you know that the source and substrate both are combined together. Source and substrate combined together. Okay. And we should give the drain is, so this is N channel MOSFET, that's why source and drain are N type materials, remaining is the P type material, and channel should be the N type material, N type semiconductor only. And always drain should be reverse bias, that's why we will give the reverse bias. So we should take, this is the VDD, and we should apply for the source normally. Okay. The first condition is if gate and source voltage is there is no 0. There is no channel means there is no flowing from source to the drain, because all are the P type materials. The number of holes will be formed, and there is no channel, there is no flow per the source to the drain generally. So that's, so for directly we will get, if the gate and source voltage is 0, simply there is no flow between source and gate, source and the drain generally. Due to the, why, what is the reason? Because there is no channel, there is no path. Due to no channel formation. So we can tell that we are giving the bias but there is no current flow between source and drain. That's why we will say it is in off condition. So we tell that so MOSFET in the off condition. Why it is off condition? There is no current flow between the source and the drain, so MOSFET in the off condition. The next point, if VGS is the positive. So for example, we are giving VGS between positive voltage. This is the positive and this is the voltage. VGS is the positive. So we are giving the positive. What happened? So if the VGS is the positive, then this is the we are giving the positive means at the gate terminal the positive ions will be formed. Whenever the gate terminal positive ions will be formed, here also the positive ions, these positive ions repulse the positive ions between the source and the drain. Automatically some positive ions will be out from this between source and the drain. This is the first condition. Okay, this is the first condition. For VGS is positive, it is possible, but in this VGS positive we have one more condition, that we should take the VDS between drain and source voltage is, for example, initially 0. We should take VGS is giving some voltage, okay, but we will take VDS is 0. We should consider the VDS is 0. Whenever VDS is 0, that means, look at here drain to source voltage is 0. There is no drain to source voltage. For example, this is 0. Just assume. And whenever VDS is 0 but VGS is positive. VGS is positive means the input voltage. Look at here. This input voltage is the positive. So that's why I am putting this positive. Then we will discuss what happened here. The holes between source and drain will pushed away. Generally, look at here. Here we have the holes because this is the p-type material. Okay. In this, from this, the holes will be pushed away. So because why we are giving the positive here, we are applying the positive. This positive terminal will be diffused it positive, then these holes will be pushed. Okay, and electrons, minority charge carriers in p channel are attracted towards gate terminal. So look at here, we have some minority charge carriers are there, but their minority charge carriers are try to attract the channel, try to attract this channel, because here positive is there, but at lower voltages are recombined. So whenever we are giving this voltage is low value, automatically it is recombined. We have some positive, so it will be recombined. So for low voltages, these p channel positive charge carriers, that means holes, are pushed away and electrons are attracted towards the gate terminal, but due to the low voltage these are recombined with the positive terminal, recombined with the holes in the p channel. So recombination is possible, but this time when VGS is increases. Next case, if we are increasing the input voltage, VGS means input increases, more holes are pushed away, electrons are rushed towards the gate terminals. So look at here VGS value is increased. In this case, this input voltage value is increased. This input voltage value is increases. Then automatically more number of holes will be pushed away. These are pushed. Holes means positive charge carriers, and electrons are rushed towards the gate terminal, because here more holes will be available at the gate channel, this channel. So then inversion layer is formed. Here the inversion layer is formed. Look at here. Look at here. This is inversion layer. Why it is called inversion layer? Because it is generally p-type body. In this p-type body, electrons will be formed a layer. That's why it is called the inversion layer. It is called as the inversion layer. Okay, right. Next, inversion layer is acting as the channel. Understand? So here our source is n-type and drain is also n-type. Then there is the formation of the electrons again. Then it is acting as the channel. Then it is acting as the channel. So look at here. N-type, n-type. There is the inversion layer. This is the channel. Inversion layer is acting as the channel at which inversion layer is forming. That voltage is known as the threshold voltage, where we are giving the input voltage now, at which voltage it become the inversion layer. Because at initially VGS low voltage there is no formation of inversion layer. When increasing the VGS, the inversion layer will be formed. At which input voltage the inversion layer is formed, then it is known as the threshold voltage. Then that voltage is known as the threshold voltage. Okay, yes, threshold voltages, right. Here we should write some statements. That is, when VGS, the input voltage, is less than VT, less than threshold voltage, there is no current flow in MOSFET. Generally there is no current flow in the MOSFET. There is no current flow. So there is no current flow. Why? Because there is no channel. There is no channel actually. This is empty. There is no channel. Here, when VGS is greater than VT, then input voltage is more than the threshold voltage. Width of the channel will increases. So by increasing this next level, whenever VGS is increases next level, the width of the channel will be increases here, because more number of electrons will be entering. The width of the channel will increase along with the channel. Okay, along with the channel there is also be depletion layer along with the channel. So here is, look at here, we have a channel. By increasing the channel, a depletion layer will be formed. Why this depletion layer will be formed? Because here p-type material is there and here the n-type material is there. This is also by all are the electrons. Whenever one p-type material and one n-type material are combined together, then the depletion layer will be formed. All of you know that this is the diodes concept. In the diode concept also it is the same principle. Okay, yes. There is also a depletion layer along with the channel, because there are two PN junctions are formed. The reason is two PN junctions are formed. One is source and substrate, another one is drain and substrate. Look at here. First is the source. This is the source, and the substrate means this channel is the substrate, PN junction. This is the one channel. Another is, this is the drain. This terminal is the drain terminal, and we have a channel. So this is also another PN junction is formed. Okay. One source and substrate, drain and substrate. Okay. Next, by applying VDS, electrons flow from the source to drain. So now we are giving VDS. VDS means, so look at here. Now we are giving here, applying the source. This is always reverse biased, positive and negative, like that. Then automatically holes will be flow from the source point, and this source point to the drain, from drain to the again the source. So this will be the electrons the flow. This will be electrons flow. Okay, yeah, electrons will flow from the source to drain. So now look at the main diagram, you will understand clearly. So here also in the main diagram, initially it is positive and it is negative. Why? Because it is reverse bias. This is the positive and this is negative. Then the holes will flow from like this. Okay, right. Next, by applying the VDS electron flow from the source to drain, channel width will decrease at the drain terminal. So here, look at here, the channel width, initially channel width is very high. After that the channel width is decreases. Channel width is decreases. So look at here, the channel width will be decreases. Why? What is the reason for decreasing the width? Here, by increasing the VDS at one voltage, pinch off condition will occur. So still increasing, the channel width will be decreases. At one point, it will become the zero channel at the drain. It will become the zero channel at the drain. That is called the pinch off condition. It is called a pinch off condition. The drain will get the saturated, at which the voltage gets saturation is known as the saturation voltage. At which voltage? At which VDS voltage? Okay, VDS means at which output voltage drain will get saturated. That is called the saturation voltage. Okay, here how we can find out the VDS saturation? VDS saturation equal input voltage, gate source voltage minus threshold voltage. We will get the VDS gate saturation. Okay, so that means VDS is fixed. VDS is fixed. Okay, VGS is the nothing but this is the input voltage. And what is VT? VT is the threshold voltage. What is threshold voltage? Threshold voltage is nothing but at which the channel is formed. Channel is formed between source and drain. Source and drain. Okay, right. For fixed value of the VGS, if we further increase the VDS, we are fixing the VGS and we are still increasing the VDS. The difference between the drain and gate terminals. So look at here. The difference between the drain and gate terminals. So these two terminals difference. Gate terminals even lesser than the threshold voltage. Sometimes it is very less than the threshold voltage. What is that? Between gate and drain terminal voltage is lesser than the threshold voltage. Due to that, the channel will not form at the drain. So that's why the channel at the drain will be zero. Will not form. The current should become zero. That's why the current is become zero. The current will become the zero. That is the reason. But still, current will flow through the channel due to the electric field. The current will become zero. So here the channel is missing, but the current will flow. Why it is current will flow? The current flow is possible because the electric field. Here we are giving positive and negative here, and due to this electric field, the current will be flow. The current will be flow. Up to this, we have a channel. It will flows. After that, it will getting. The electrons will be attracted. So that's why it is flowing. Okay, the reason for is electric field. Electric field is the reason. Due to the electric field, the current will flow. Okay, right. So now we will discuss the transfer characteristics. We will discuss the characteristics. How by varying the VDS, how the drain current is flowing. How the drain current is flowing. What is VDS? We can name it as the output voltage, and we should take it as the output current. ID is the output current. Here at initially up to the threshold voltage, the layer will not be formed. Here threshold voltage, the current layer will be formed, that will be 0. When slowly VGS is increases, VGS is putting it 3 volts, by increasing the VDS it will increase some value and will become the saturation. And next, now we are increasing the input voltage, VGS equal 4 voltage. By increasing the VDS it will follow this curve, so the curves will be increases like this. So look at here, this VGS are the nothing but the input voltages. Input voltage will decide the current, and VDS is the output voltage, and the ID is the output current. ID is the output current. So if you clearly observe here, so at this region the current will be 0. At this region the current will be the 0. So then this is known as the cutoff region. Then this is known as the cutoff region. And at this region the current and voltage will be linear mode. The current and voltage will be in linear mode. Okay, so this region is known as the linear or ohmic region. Linear or ohmic region. Linear region means in this output voltage and output current both are linear condition. By increasing the voltage, the current will be increases in the same manner. That's why it is the linear region or ohmic region. And what about this region? What about the remaining region? In this region, if you observe, the output current will be saturated. That means output current will be fixed, but by varying the output voltage. We are varying the output voltage VDS here, but the current flow in the drain will be the fixed. That's why this is called the saturation region. That's why it is called the saturation region. Understand? Yes. So these are the, so we can tell the two conditions by analyzing this circuit. What are those? The first condition, we can tell that what is cutoff region? Cutoff region is, so we will tell the cutoff region is when input voltage or gate source voltage is less than the threshold voltage. Generally MOSFET we can tell off condition. MOSFET in off condition. Understand? Must and should, we should maintain VGS must and should more than the threshold voltage. Then it will acting as the switch. So we will tell next the saturation region. What is the saturation region here? In order to get the saturation region, the VDS value must and should greater than VGS minus VT. We should give the output voltage to must and should greater than the VGS minus VT. Then that region is known as the saturation region. Okay, so if you observe these characteristics similar as the we know that it follows the BJT characteristics. Bipolar junction also the same region, but we can call it, this is the active region, and we will call this is the on region, saturation region. The regions will be different. Okay, the regions will be different. Yes, but here whenever at zero current, it is called as the cutoff region. At diode drain current is the constant, saturated, then the saturation region. When output current is follows the input current linear, then it is called the linear region or the ohmic region. Okay, so this is the characteristics, this is the working of the enhancement type MOSFET. Enhancement MOSFET is very important because it doesn't have any channel. It induces inside the channel by this process. But the channel will decide by this VGS, that means the input voltage, and by applying the output voltage we will get the current. That current characteristics are like this. Okay, I hope all of you understand this session, and it is very important MOSFET. It is highly applicable than the depletion type MOSFET. Okay, I hope all of you understand this session. Thank you.